Okay, so we did a little exit ticket today where I had you describe this graph to get some feedback, and I'm just going to take the time to go over my explanation because I'm not going to be in tomorrow, so that way you can take a look over the weekend and hopefully get some points clarified. So there's a couple points on here that could go multiple ways that I would accept, so I'll mention what those are and kind of explain the thought process there. So when we're looking at this graph, first thing we're going to name is the shape. The best answer is cubic. When I wrote this equation, I did use a cubic function. However, we haven't fully explored those yet. So anything that's kind of describing the shape will work. If you said S-shaped, if you said N-shaped, some of you even said trig, I would take any of those right now because without the formula, there's no way to know for sure. One thing to keep in mind for trig, that almost always refers to when you have an oscillation that goes up and down, versus having one side that eventually just goes down. So if this came back up, that would be more trig-like. But technically anything along these lines I would take. The only ones that you should know for sure, if it's something straightforward like line, exponential, or parabola, those should be clear-cut. The rest, there may be some variety there. Okay? Next up, domain. What I want you to think about is sandwiching this graph left and right based on the x-axis. So I'm going to sandwich left and right something, let me flip these over, something like so, okay? And then the observation we want to make is we want to go from the left-hand side to the right-hand side. We want to go small to big. Now on the left-hand side, I'm touching an arrow, which means that line goes on forever, so I have an infinity. Infinity always gets parentheses, technically negative because I'm on the left-hand side. And on the right-hand side, I hit right at 1. That is a closed dot, so it's an included point, and it would get a bracket. So my domain would be parentheses, negative infinity, to positive 1 with a bracket. Okay? Moving along to range, I'm going to do the same thing, but I'm going to sandwich top and bottom. So I can imagine sandwiching something like this. Okay? But again, on the lower side, the lower bound, I hit an arrow, which means it goes on forever, or negative infinity. Again, infinity always gets a parentheses, and from the top, I hit a maximum y value of 1.54. It has a closed dot, so I would have a bracket. So my range would go from negative infinity on the small side all the way up until 1.54 in terms of the biggest value. Okay? Our domain and range is just sandwiching. Remember, infinity always gets parentheses. Included numbers get a bracket, so if you have an open circle, that's when you might get parentheses for an individual number. Okay? This one, there's some, I'm going to say best answer and then an answer I'll take for sure. The best answer lists every value or every descriptor from left to right and tells you when it switches. So the best possible answer would be to say this. I start my graph reading from left to right and I am increasing until I reach x equals negative, I'm down here now, 0.577. Then I'm decreasing, and I'm decreasing again and again and again until I reach x equals positive 0.577. And then finally my graph is increasing until I get to x equals 1 because it stops. That would be the absolute best description you could tell me. However, at the very least, you should describe everything from left to right. So I would want to say increasing, then decreasing, then increasing. Okay? I don't care how many switches you might have, you should describe every trend from left to right. So my graph is increasing, going up, then it's decreasing, then it's increasing again. Okay? Next trait, continuous or discrete, pretty straightforward on this particular graph. It is continuous, it is smooth all the way through, all connected points, there are no breaks or gaps. Then we get to x-intercepts. I have 3 of them. Here, here, and here. All 3 are x-intercepts. They're all on my x-axis. Okay? I should list all of them. Doesn't matter if there's 1, 2, 3, none. As many as there are, I should list. And do note, I listed them as ordered pair of points. -1, 0, 0, 0, 1, 0. Our intercepts will always be points. Now in terms of the y-intercept, I'm looking right here on the y-axis, and I cross it at one point, right here the origin, which is 0, 0. So I would take that, okay? And it is possible to have the origin be both an x and y-intercept because it is crossing both axes. Okay? Going on to 6, function. Yes, it is. If I imagine a vertical line test, as I go from left to right, I am only ever crossing the graph once. Therefore, it is a function. Each input has exactly one output, passes the vertical line test. Yes, it's a function. Do I have any asymptotes? Not in this case. Nowhere do I see my line or my curve kind of approaching a line and not quite hitting there, so I would have none. So I don't need to worry about that. And then finally 8, max and min. And I'm going to explain something new with this one. So when we talk max and min, it gets a little tricky. Maximum, I think, is a little bit more clear-cut. If I look at this graph, it has a maximum. That is the highest point that will ever be reached, right here, okay? And I listed that point. I wrote max, I wrote negative 0.577, comma 1.54. Ignore the part in green for a moment. That is clearly a maximum, okay? Now when I come from the bottom, we want to say that this point's a minimum because it looks like one, right? Our graph kind of bottoms out. But there's the issue that over here our arrow goes on forever, so technically no matter what point you give me, I could always go lower down this direction, okay? So here's what I'm going to do. I'm still going to call this a minimum because it clearly looks like a minimum. It looks like my graph's bottoming out. And I'm going to say that it is minimum 0.577, negative 1.54. Notice for both the max and min, I listed the entire ordered pair. Not just the y value, but the entire ordered pair. I want to know where it is on the graph, okay? Now here's the distinction we're going to make between the two. The first one we would describe as absolute. That is the absolute highest or the absolute maximum that the graph ever reaches. Now this other one, while it behaves as a minimum, technically the graph goes lower. So how do we describe it then? We say that it's relative. It is a relative minimum. Compared to this portion of the graph, it looks like a minimum, even if somewhere else on the graph gets lower, okay? Often we're interested in those kinds of points because they often mean important things when we're solving real-world problems. They represent your profit or your losses until you have to close your business. They represent important values, so we're often interested in them. In terms of the test next week, you should be able to identify max, list the entire ordered pair, minimum, list the entire ordered pair. If you remember absolute or relative, that would make me incredibly happy. But if you don't quite remember what that means, or you forget to put it on there, you won't get marked down if you don't have it, okay? Also, if we looked at this and so I'm just going to stop there. So, hopefully this makes a little bit of sense. Please take a closer look at the categories that you're not sure about, especially interval notation. That's one that I want to get going pretty easily. The rest of these I hope should be pretty straightforward looking at the graphs. Shape might be a little more weird, but as long as you put down something reasonable, it'll almost certainly work. There's a little flexibility right now because we haven't explored too much. We're still doing that. Happy studying. I hope you have a productive weekend, and I will see you on Monday.